Working on speed and time graphs, the game changes a bit because it really, I mean, like just like distance, the very first thing you need to kind of look at is, well, the first thing you need to look at is this y-axis, and the thing is, speed. We're talking about the rate of movement. I know that sounds strange. And we have different ways of calculating that, or not necessarily calculating that, but measuring that. Easily the most popular is miles per hour. Essentially, what that involves is, well, we need to have distance, which would be miles, and a unit of time, which happens to be hours. All right. But with speed, if we look at this, we notice that, a lot of us would consider this not movement or no movement whatsoever, but in fact, the speed is constant. We have the same amount of speed, and where this differs with distance, like a constant speed with distance is more diagonal. It's not even going to let me do that. It's more like this. Whereas with speed, it's just a horizontal line. So this is where the game kind of shifts and changes. All right. But it's your understanding of the y-axis. All right. So here, with speed as our y-axis, this is actually showing gaining speed. You're getting faster. I mean, also known as accelerating, but that's a touchy term with this unit, because accelerating just means a change in position. And that's very strange. I know. I haven't fully wrapped my head around that. And it's been 10 years teaching this stuff. So this is where we're gaining speed. We actually see the speed going up. And that's important because, with distance, this looks like constant speed. And that's where it all kind of gets jumbled up. So if you're not going to pay attention to the details here, you're basically in a little trouble. But I'm telling you, focus on that y-axis. Like, that's everything. Speed, if my speed is doing this, that means I am losing speed. So it's deceleration or decreasing speed. So, I mean, speed to me is the easiest of the two. But it also combines with distance to confuse you even more. But that's where you have to, early on with your thinking, establish that y. The y-axis, right? The y-axis, like, that's everything. Once you get your y-axis established in your thoughts, it actually becomes a lot easier from that point on. But those who kind of fling themselves at information without really paying attention to what's going on, this becomes extremely confusing. All right. So just like as we had in the distance, and some of you are like, it's the same thing. No, it's not, because our y-axis is speed now, not distance. And here, the dotted line is much faster than the solid line. Therefore, if they were running a race, the dotted line wins again, because they finish in less time. And sometimes it's good to have like a sheet of paper to kind of put where these lines end, so you can kind of get a reading of the time. But since we do not have any actual time being shown here, I mean, this could have been a few seconds or a few days, who knows? That's kind of it with that. Here we have a motion, speed, and time graph. This is steady acceleration. This is constant speed. This is where you're speeding up. And the way I kind of like look at this is like being on the highway. We're trying to pass somebody, so we speed up. Then, a traffic jam's coming, so we have to, not necessarily slam on the brakes, but slow down gradually. Yeah, and this is where, in speed, you're not going to see, very many curves, and that's really important to understand too. You'll definitely see the curves with distance, but you can. I mean, but for the time being, we just need to really focus on the y-axis, and how speed differs from distance, and how that looks being graphed. If we look here, I want you guys to, let me zoom out a little bit. I'm on the wrong page. There we go. Sorry about that. I don't want to zoom in, I want to zoom out. All right, so what I want to do here is I want you to look at these. Which one indicates a car stopped? Which one, a car traveling at a constant speed? Like the car is accelerating, the car is slowing down. All right. Let's go with 5 first. The car stopped. Well, that would be H. And we notice here there's no speed at all. How it's laying on the x-axis, indicating no speed. Number 6, the car is traveling at a constant speed. Which one do you think that is? And this is where, I mean, if you think about a stopped car, there's no speed at all. So which one's showing a constant speed? And this is where it gets a little strange. And that would be G. The speed is not changing. It is, do we know how fast they're going? We don't. But, for this kind of model, it doesn't really matter yet. Number 7, we got to show a car gaining speed. Well, I mean, just think of up and away. We're gaining speed. The speed is getting faster because it's going up. And then this is decelerating or slowing down. We're losing speed. So speed to me is easier out of the two. Distance can be kind of abstract. But these next couple days, whenever we actually look at this stuff, and compare them, hopefully that will begin to become more concrete with your thoughts. And that is it.